we're going to look at how to reconstitute a medication and then administer it. So this is our label right here, and this is what we're going to look at to answer the questions. So our first question is, what is the total strength of the vial? To find that, you're going to look right here, and this tells you the total strength of the vial. This vial contains 1 gram of the medication. So we'll put 1 gram right there. Our next question is, how much diluent is recommended for reconstitution? Now, the important thing to look at here is that you have to notice that there are 2 different sections that we can reconstitute, intramuscular and intravenous. So we have to look at the order to see how much diluent we would use. And our order is for intramuscular. The other thing that you need to notice is that this label is created for multiple different vials. So if we were giving this by intravenous infusion, you could have a vial that has 1 gram or 2 grams. You need to make sure that you are looking at the right vial strength if we were reconstituting this for intravenous infusion. But for this equation, we're going to do intramuscular. So that one we're going to look right up here. It is a 1 gram vial, and we are going to add 3 mLs to reconstitute the solution. The next question is asking you what type of diluent. What are you going to add to the vial to reconstitute this medication? And up here it tells you sterile water for injection. So that is our answer, sterile water. You can also add the for injection. So you do need to understand that anytime you are injecting a medication, IM, IV, sub-Q, ID, what you're injecting needs to be sterile. If we were reconstituting an oral medication, we drink tap water, so the water wouldn't necessarily need to be sterile. There are a couple of exceptions if you have a neutropenic patient and you're worried about infection, but generally speaking, when you are reconstituting an oral medication, you can use tap water. The next question is, what is the dosage strength or the final concentration when the medication has been reconstituted? So on the label, it will tell you. Right here is the approximate average concentration. This is our dosage strength for the IM injection, since we have reconstituted using 3 mLs of sterile water. So that is 280 milligrams per milliliter. Remember that your dosage strength needs to be expressed as some form of dosage per either a milliliter, a tablet, a caplet, 5 milliliters, but some unit of measure. Our next question is, what is the total volume of the reconstituted solution? And it tells you that right here. Approximate available volume is 3.6 mLs. 3.6 milliliters. Now, occasionally you may be asked what the displacement volume is. The displacement volume is when you have added 3 mLs, it is what you added, the diluent you added. You look at the total volume, which is 3.6 mLs, and you subtract the total volume minus how much you added the volume of the diluent, and that would give you 0.6 mLs. The displacement volume essentially is how much powder was in the vial. You do not figure this out on your own. It would be on the label. Certain labels do not give you the approximate total volume after reconstitution. I just included this because I've seen certain textbooks ask that question. Now, the routes of administration, it's just like any other reading the label problem, and you would find that right up here. For IM injection, IV direct bolus, or IV infusion. I would just write IM or IV. How many milliliters will you administer? Now this is a dosage calculation question. So the order was for 420 milligrams. What we have available is this dosage strength, 280 milligrams in 1 ml. So when you multiply across, you get 420 over 280. Which is equal to 1.5 mLs. So that is how many milliliters we would administer. Then the question asks, how long will the reconstituted material retain its potency? And this is a very important question. The whole reason we have to reconstitute medication is that if the manufacturer sent it out already mixed, it might not reach the patient in time to be effective. So somewhere on this label, it will tell you how long it is good for, rather. So on this label, it's right here. It tells you 18 hours at room temperature or 7 days if refrigerated. So I would be writing all that on the label. Rather, would be writing that as the answer. Now, the last part of this question tells you to mark the syringe with appropriate volume. We know that we're giving 1.5 mLs, that's written right here. So when you look at the syringe, you start at this end and work your way backwards towards the plunger. So here's a half an ml, here's 1 ml, here's 1 1/2 mLs. That is where I would fill the syringe to with this medication to administer to the patient.